Okay, this lesson is just there to provide a little bit of help on your homework dealing with the arrow problem. Again, please do not look at this until you've actually tried the homework. And if you need help, this is what the help's for. Pause it, try it, look at a hint, hit pause, try it on your calculator, see how you do. Okay, problem number 1, dealing with this arrow problem. I think this is how I introduced the whole unit. So let's see what we've got here. So you're shooting the bow. So hint number 1 right here. Draw the right triangle, convert miles per hour into feet per second. So why don't you pause, make sure you did the right thing. Welcome back. Hopefully you did, and you got 44 feet per second. Hint number 2. See if you wrote the correct parametric functions. So are those the parametric functions you got? I hope they are. Now take that, see if you can finish this problem on your own. And there's hint number 3. Take some time, make sure you did this the right way. Now, having seen all that, why don't you try the next part of this problem, see if you can get it right. And if not, come back to the video and watch part 2 here coming up. All right, here's part 2. So, what's the first hint? All right, so hopefully you have used your x function from previously to see how many seconds it'll take the arrow to travel 45 feet. You might want to pause it. There's my answer. Hint number 2. Take that value for t and plug it into the y value to see how high you are 45 feet away. And now for the last part. Hint number 1. Make sure you have Robin's correct arrow speed. Again, we had to convert that into feet per second. Now, hint number 2 involves figuring out the parametric equation for Robin Hood here. We have your parametric equations from previous in the problem, but what about Robin Hood's? So first of all, here's what I got for his x value. Again, why is this x value for Robin Hood a negative value? Well, think about it. Robin Hood is firing in the opposite direction you were. So you were firing to the right, which is positive. He's firing to the left, which is negative. And he is 150 feet out. Oops, I should probably change this down here to 150. Oops. And it's negative. Now, another way to think about this is think about the unit circle. In the unit circle, when we are dealing with polar graphs, we know that this is 0 degrees, this is 90 degrees, this is 180 degrees. Robin Hood is firing in this direction, from here that way. What is the cosine of 180 degrees? Well, the cosine of 180 degrees is -1. That could be another way you think about where this negative came from. And finally, what about the y values? Now this part I think is very tricky for kids, and I think they really struggle with the y values here. But this is the y value I got. And let's talk about this. The -16t squared we know is gravity. As soon as Robin Hood fires off his shot here, it's not going to go straight, but it's going to go downward in a, well, actually in a more of a parabolic form. It's going to want to go straight, but it's going to go downward. And that's because of gravity. Now, the plus 65 is because he's 65 feet up in the air. But you might be wondering, what about the middle part? Up here, after all, we had a middle part. Well, remember, Robin Hood is firing that arrow horizontally. So there is no angle going up. As a matter of fact, you could think of his angle as being 180 degrees. I mean, if you wanted to, you could put right here plus 74.8 t times the sine of 180 degrees. Well, what is the sine of 180 degrees? Isn't that 0? I mean, this is just 0, so we don't even need to include it. Since there was no initial angle and he's firing back towards us this way, you could think of that as this. And of course, that is moot. It's 0. So now that you've got these two parametric functions involved, you could solve this algebraically. And what I did is I set this y value equal to this y value and found how much time it took for these two arrows to be at the same height. And once I found the time, I plugged those times into the x values to see exactly what their horizontal distance was. Now, let's take a look at this on the calculator. I'm going to go ahead and type these values into my calculator here, and let's see what we get. So for x, I want 44t times the cosine of 64. And my y will be negative 16t squared plus 44t times the sine of 64 plus 3. I think it was 3. Is it 3? It's 3. Now for Robin Hood's arrows, we're going to do negative 74.8 t plus 150. And for his height, negative 16 t squared plus 65. Now, let's go to our window. I think for time we should be okay with 6 seconds. That's kind of a lot of time. X max, let's see, I think Robin Hood is 150 feet away from us, 150. And I think his height, he is 65 feet in the air. We should be okay with 75. Let's make that 70. Okay, let's graph this and see what's going on here. Now, remember, the inner button will pause that graph. So 3 feet above the air, there's our arrow. Here comes his. Get ready to pause it now. Okay, what's going on? Well, that was a delayed pause. Anyways, we see that they came really close to hitting each other. I'm going to break this graph. I'm going to try that again. I know I can do better. Let's hit graph. All right, here we go. Now let's see if this guy is going to cooperate this time. All right, here we go. I'm going to hit the enter button early. All right, that didn't work either. This calculator is not cooperating. Anyways, I think it's pretty close. We can actually go in and look at the table setup. We knew that these two graphs hit each other right around 1.56 seconds. So maybe I'll do 1.5 and I'll go up by 0.01. And let's check that table out and see. All right, so we can take a look at when the x values are the same or the y values are the same. Look at this. Look at this. These y values, these x values, they're so close to each other. Look at that right there. Look how close those are. Yep. So you can make the argument either way as to whether they hit or not. That is up to you. All right, you have one more problem set, and that is dealing with the golfer. So give that a go and see how you do. Take care, everybody.